Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking, assume that a digital system to be designed has 16 n-bit register R0 to R15 with load enabled and output enabled inputs, 3 state outputs. It needs to implement the following microops that needs to be executed concurrently if there are no constraints on hardware cost. Otherwise, they should be executed while satisfying the hardware cost and speed constraints. R1 goes to R2, R3 goes to R6, R5 goes to R4, R1 goes to R7, R5 goes to R11, and R7 goes to R8, R3 goes to R9, R7 goes to R12. Design the digital system using buses for the following case. Assuming that all microops needs to be completed in 2 clock cycles or less, the hardware constraint is that no more 2 buses should be used. For each case, describe the microops executed in each clock cycle and also the bus used for implementing that microops. Now let's go ahead and see how it's going to look like. Now first I'm going to draw the bus line 3 state buffer, 3 state buffer. It's going to look like this. First we have A0, B0, C0, D0, and we connect all of them like this. And here we will have a multiplexer S1, S0, enable, and here we have 0, 1, 2, 3. These two are select, and this one is enable. Now this one connected to 0, and this one connected to 1, and this one connected to 2, this one connected to 3, and all of them are connected to bus line bit 0. The bus line bit 0 comes from the first one, bus line for bit 0, and we connect all of them here. And that's the design. Now let's go ahead and explain the design. Okay, this is sequence of register transfer of R2 from R1, R6 from R3, R4 from R5, R7 from R1, R11 from R5, and R8 from R7, R9 from R3, R12 from R7, and first T0, R2 coming from R11, and R7 coming from R1, T1, R6 coming from R3, and R9 coming from R3, and T3, R4 coming from R5, and R11 comes from R5, and T4, R8 coming from R7, and R12 coming from R7. Okay, Now here what we did, only 2 or less clock cycle using only 2 or less clock cycle using T0. R2 comes from R1, and then R7 comes from R1, and R6 comes from R3, and R9 comes from R3. Here T1, R4 comes from R5, and R11 comes from R5, and R8 comes from R7, and R12 comes from R7. And that's how we did it. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn digital logic design too, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.